Assalamu alaikum. How are you, dear students? Welcome to the channel, The Physics Gurus. So this is the part number 7 of the definition series of O-level and IGCSE physics for the syllabus 2022. So in part number 7, we will discuss the definition related with unit number 13, that is general wave properties. So let's start that unit. The very first definition, what is meant by wave? Wave is a source of transferring energy from one place to another place due to the disturbance in the medium. So what is wave? Wave is a source of transferring energy from one place to another place due to disturbance in medium. Like, for example, light waves, heat waves, sound waves, etc., etc. Then the definition of ripple tanks comes over here. So ripple tank, a device which is used to produce water waves and study their characteristics, is called as ripple tank. In exam, sometime examiner asks to draw the diagram of the ripple tank and label it. So this is the transparent block. Block or tray, you can say. It is filled with water. Here you have placed the screen. Here is the motor. It is connected with the vibrator. And in order to view the waves more clearly, we have hang the bulb over here. So in this way, simply you can draw the label diagram of the ripple tank. So you have to label the different parts of the ripple tank as well. Okay. Next comes the definition of phase. The points on the wave are in phase if they are at the same displacement and moving in the same direction. Let's suppose if we are having these type of two waves, then these 2 points are supposed to be in the same phase because their displacements and their directions are the same. But if we will consider these 2 points, now these 2 points, number 1 and number 2, these 2 points cannot be considered in phase because they are not moving in the same direction at the same time. Then here comes the definition of wavefront, and this is the very common or very famous definition which is being asked in the examination regarding waves. So what is wavefront? Let's suppose I'm going to draw the wave number 1 like this, and then wave number 2 like this. Now I will draw, okay, it is an imaginary line on the wave which join all the points which are in same phase. Let's suppose if I will consider these points, point number 1, point number 2, point number 3, point number 4, 5, and 6. Now if I will join these points, then these points are called as wave fronts, and usually they carry whole of the energy of the wave. So what is wavefront? It is compulsory or mandatory that you have to write down the word. It is an imaginary line on a wave that join all the points which are in the same phase. Then here comes the next definition, that is amplitude. The maximum displacement of a wave above or below the mean position. Let's suppose if I'm going to draw the wave like this, then this line is called as mean position or equilibrium position as well, or it can be also termed as normal position. So different terms can be used for this line. So now what is amplitude? Amplitude is the maximum displacement from the mean position. If I will draw this, I will draw this, I will draw this. So point number 1, point number 2, point number 3. So which line shows the maximum displacement? Definitely line number 3 shows the maximum displacement. So this point will be considered as amplitude, and usually amplitude is represented by A. Since this is the distance, so its unit can be meter or centimeter. Likewise, this can be also the amplitude of the wave. Then here comes another definition, which is very important definition. That is the definition of frequency. Frequency is denoted by smaller. And what is the definition of frequency? Number of oscillations, vibrations, or waves passing through a point. And what will be the time duration? In 1 second. So number of waves passing through the point in 1 second is called as frequency. So you have to mention the two words, number of waves along with the point, as well as 1 second. And what is the definition of time period? Time period is the time required to complete one oscillation or one vibration or one wave. And time period is represented by capital T, while simple time duration is represented by small t. So never ever mention the time period with small t, but never ever mention the time duration with capital T. And what is the relation between frequency and time period? They are inversely proportional to each other. That is, F is equals to 1 over T. What does it mean? Larger the frequency, smaller will be the time period, and smaller the frequency, larger will be the time period. Let's suppose that what is the frequency? How many waves are there? So there are 2 waves. Frequency is 2 hertz. And for this, there is only 1 wave. So frequency is 1 hertz. So larger the frequency, smaller will be the time period, because time period is the time to complete 1 wave. So that will be the time period for this wave, and smaller the frequency, larger will be the time period. So time period and frequency are inversely proportional to each other. Then definition of wave speed is there. Distance covered by the wave per unit time. What was the definition of speed? Distance covered per unit time. Since this is the wave speed, so we have to add the word wave, or you might write the definition without adding the word wave as well. Distance covered per unit time is called as speed. And speed is denoted by small v, and its formula v is equal to s over t. So distance over time, and its unit will be meter per second. Then here comes the major types of the wave, that is transfer waves and longitudinal waves. So what is meant by transfer waves? The source of transferring energy in which particles of medium vibrate. This is the key word. You have to mention the word vibrate. You are not supposed to mention or write the word move or movement. And then another important keyword, that in transfer waves, particles of the medium always vibrate to the perpendicular of direction of propagation of wave, or to the perpendicular to the energy transfer. So examples of transfer waves are light waves, X-rays, water waves. And transfer waves will be like this. Now there are 2 parts of transfer waves. Number 1, crest, and number 2, trough. The part of the wave which are above the normal position is called as crest. So this point, this can be the crest, this can be the crest, this can be the crest as well because it is above the normal position. But in generally we assume the highest point from the mean position is called as crest, and the lowest point below the mean position is called as trough. So crest and trough. Let me draw the wave like this as well. So this will be the another trough. And then definition of trough, the parts of the wave which are below the normal position. Crest are the parts of the wave which are above the normal position, and troughs are those points which are below the normal position. Then there comes the definition of wavelength. Wavelength is denoted by the letter lambda, and its unit will be meter or centimeter. So the distance between two consecutive crests or troughs. You are not supposed to write down the definition like this, the distance between two consecutive crests and troughs. So the distance between two consecutive crests, this can be the definition, or you can write the alternate definition, the distance between two consecutive troughs. So this will be the crest, and this distance will be the wavelength, and this distance also will be the wavelength, or the distance of the wave is also called as wavelength. But in terms of transfer waves, we have to mention that the distance between two consecutive crests or the distance between two consecutive troughs. Then here comes the second part of the wave, that is called as longitudinal waves, and its alternate name is compressional waves. So the source of transferring energy in which particles of the medium, again which word, vibrate. Now you can write parallel to the direction of propagation of wave or in the direction of propagation of wave. You can use both the phrases. For example, only there are two examples of the longitudinal waves, sound waves and seismic waves. Seismic waves are produced when there are some sort of earthquakes are there. There are two parts of longitudinal waves, compression and rarefactions. Now, if I am going to draw this, then and why these were called as transfer waves? Now you can see that the wave is traveling from right to left, and particles of medium are vibrating up and down. So what is the angle between these two? 90 degrees. Okay, so now in this diagram, there are two parts of the, now why these are called as longitudinal waves? Because wave is traveling from left to right, and these parts are also vibrating like this. So they are in the direction of parallel to each other. Now there are two parts of transfer waves, compression and rarefactions. C is representing compression and R is representing rarefactions. So never ever write it refraction. This is the word rarefaction. So what is the definition of compression? The parts of the wave where pressure between the particles of medium increases, or where particles of medium are close to each other. Now you can see these particles are close to each other, and in rarefaction these particles are far apart. So compressions are those points where particles of medium are close to each other. Now we have to mention the wavelength, the distance between two consecutive compressions or the distance between two consecutive rarefactions. So if I will start from the middle line of the compression, then wavelength will be completed. And if I have to mark the distance between two rarefaction, if I am going to start from the first rarefaction, then this distance is also called as wavelength. And there is a very famous equation, relationship between speed, velocity, and wavelength. that is V is equals to F lambda. By changing the medium, frequency does not change, but by changing the medium, velocity and wavelength changes. Let's suppose that when water waves travels from deep to shallow water or from shallow to deep water, then frequency remains same, but wavelength and speed changes. When it turns from deep to shallow water, speed decreases due to which wavelength also decreases, but frequency remains same. And when waves enter from shallow to deep water, velocity increases due to which wavelength also increases. So I hope so that now the definition related to the unit general wave properties are clear to all of you. And if there is any question, you may ask or you may write the questions in comments. Thank you very much. Always stay blessed. Allah Hafiz.